Dear students, in this video, I am going to solve one numerical problems appeared in the year September 2020. Let's see the first problem. In the parallel plate capacitor with air between the plates, each plate has an area of 6 into 10 raised to minus 3 meter square and the distance between the plate is 3 millimeter. Calculate the capacitance of the capacitor. If this capacitor is connected to 100 volt supply, what is the charge on each plate of the capacitor? Here we need to find out two parameters. One is capacitance of the capacitor, and another one is charge on each plate of the capacitor when that capacitor is connected to 100 volt supply. So here we know that an expression for capacitance of the capacitor is epsilon R A divided by D. Epsilon R, this is the value of dielectric medium which is placed between the two plates of the capacitor. So, but in this problem, there is a air in between the plates of the capacitor. So, epsilon R, that is the relative permittivity for air, is 1. So, we could write this one as, that is epsilon naught A divided by D, because epsilon R for air is 1. So, that we can write epsilon naught A divided by D. So, here we have epsilon naught value, that is 8.854 into 10 raised to minus 12. And the area of the plate, here we have 6 into 10 raised to minus 3 meter square divided by D. The distance between the two plates is 3 millimeter. 3 millimeter means 3 times 10 raised to minus 3. So here 10 raised to minus 3, 10 raised to minus 3 get cancels. 3 1 ja, 3 2 ja. 8.854 into 2 is 17.708 into 10 raised to minus 12. Farad. So this can be written as 17.708 picofarad. This is the capacitance of the given capacitor. Now suppose if it is connected to 100 volt supply, what is the charge on each plate of the capacitor? So basically we know that capacitance of the capacitor is equals to Q divided by V, that is charge stored on each plate of the capacitor to the potential difference applied across the ends of the capacitor. So charge on each plate of the capacitor can be written as CV. So just now we found C, that is 17.708 picofarad. Pico means 10 raised to minus 12. So voltage applied is 100. So it becomes 17.708 into 10 raised to minus 10. 100, 10 raised to 2, 10 raised to minus 12. So it will become now 1.7708 into 10 raised to minus. We could write like this. Or else we can express like 1.7708 nanocoulomb. This is the charge stored on each plate of the capacitor. Okay, let's go to the next question. In the given circuit, calculate the current through the galvanometer. That is, we need to find out IC. So in the circuit, the current flowing is I, and at the junction A it splits up into two parts, that is I1 and I2. And at the junction B, this I1 current splits up into IZ and one more current, let me mark this one as I3. And at the D, that I2 as well as IZ combine together and then they will flow through I3, that let me mark it as I4. That is at the junction D, I4. So at C, I3 and I4 combine together and then will pass through battery, that is I. The current through the circuit is I. So here at the junction A, we can mark this one as I equals to I1 plus I2 at the junction A. And at the junction B, we can write this one as I1 is equals to I3 plus IZ. By applying junction rule, we can write at B like this. And at the point D, we can write that I4 equals to I2 plus IZ, because we know that sum of the current entering the junction is equals to sum of the current leaving the junction. So we could write here at A, B, C, at A, B, D. And at C, we can write that I4 plus I3 plus I4 is equals to I. That is I equals to I3 plus I4 or I1 plus I2. This is at C by the junction rule. Now, to find out current through the galvanometer, let me apply KVL to the loop ABDA. Let me apply KVL on applying KVL to the loop ABDA like this. Let me consider the direction ABDA. So now we need to consider IR product, no? So here IR product should be considered positive whenever the direction of the current and direction of the consideration is same. If the direction of the consideration and direction of the current is opposite, then the IR product should be taken as negative. So here I am applying KVL to the loop by considering the sign convention. So we can write here I1 into resistance is 1 ohm, so we can write I1. Because of what reason I have taken here plus, because direction of the current as well as direction of consideration is same. Here plus we are taking because direction of the current IZ as well as direction of consideration is same. So we can take here IR product as 5IZ and minus here direction of current is from A to D, whereas direction of consideration is from D to A. So it should be taken as negative. That is 4I2 equals to 0. Let me consider this equation number 1. In the same way, I am applying KVL, that is Kirchhoff's voltage law, to the loop. Let me consider the loop BCDB. So here we can write IR product as 2I3. It should be taken as positive because direction of the current and direction of consideration same. And here minus because it should be considered minus. That is I4 into 3. 3I4 minus 3I4 because direction of the current is from D to C, whereas direction of consideration is from C to D. So minus I2. And here minus 5IC is equals to 0. So let me substitute I3 and I4. Here I3 equals to, so according to junction rule, I3 becomes I1 minus IZ. That is I1 minus IZ. And here I4 is equals to what? I2 plus IZ. So same thing I am substituting here. That is I3 equals to I1 minus IZ minus 3 of I4. In place of I4, I2 plus IZ minus 5IZ is equals to 0. I am simplifying, get 2I1 minus 2IZ minus 3I2 minus 3IZ minus 5IZ equals to 0. This is equals to, here we have 2I1. Let me write first I1, 2I1, here 2IZ, 3IZ, 5IZ, totally 10IZ and minus 3I2. Let me consider this one as equation number 2. On applying KVL, let me consider one more equation by applying KVL to the loop ADCA. So let me consider the direction from ADCA. So now we can get I2 4, that is 4I2. IR product is 4I2 plus 3I4 plus the current is I and here interresistance is 1. So we can write here I equals to the voltage across this loop is 3 volt. Now on substituting I4 we get 4I2 plus 3 of I2 plus IZ, and in place of I should write I1 plus I2 equals to 3. Now here we can write 4I2 plus 3I2 plus 3IZ plus I1 plus I2. Now simply we get I1. Let me write first I1 here. Next let me consider IZ, that is 3IZ plus 3IZ, and here I2, 4I2 plus 3I2 plus I2, so plus 8I2 equals to 3. So let me guess, this is equation number 3. In this way, first we need to create the equations, simultaneous equations, by considering the number of loops. Next let me solve these equations to get Ig. Okay. So here equation number 1 is I1. Let me write first equation number is I1 plus 5Ig minus 4I2 minus 4I2 equals to 0. This is equation number 1. Next, let me write equation number 2 is 2I1 minus 10Ig minus 3I2 minus 10Ig minus 2I2 equals to 0. This is equation number 2. That is 3I2. Right here 3I2. This is 3I2 equation number 2. So to get Ig, first let me eliminate I1. To eliminate, first we need to multiply by 2 this one. So if you multiply by 2, then what would happen? Let us see. The equation number 1 becomes 2I1 plus 5 into 2, 10Ig minus 4 into 2, 8I2. This is equals to 0. And here as it is, let me write the equation number 2 as it is, that is 2I1 minus 10Ig minus 3I2. So here at the time of cancelling, the sign changes. So 2I1, 2I1 get cancels. 10Ig, 10, 20Ig, that is 20Ig minus 5I2 equals to 0. Let me consider this equation number 4. Now let me solve equations 1 and 3. Equation 1 and 3. So here equation number 3, here we have, that is I1 plus 3Ig, I1 plus 3Ig plus 8I2 equals to 3. This is equation number 3. And let me solve equation number 3 and 1. Equation number 1 here, 5Ig minus 4I2 is equals to 0. This is equation number 1. I am solving this one. Let me cancel I1 here. If I cancel this I1, we get minus 2Ig, and here we get plus 12I2 is equals to 3. Let me guess, this is equation number 5. Okay. To find out Ig, let me solve fourth and fifth equation. So here we have fourth equation is 20Ig minus 5I2 equals to 0. And here 2Ig minus 2Ig plus 12I2 equals to 3. Okay, this is equation number 4 and this is equation number 5. To cancel I2, let me multiply equation number 5 by 12 and let me multiply this equation, that is 5 by 5. So then what happens? You see, 12 into 20, that is 240 Ig minus 60 I2 equals to 0. Here 2 into 5, 10 Ig minus 10 Ig plus 12 I2, that is 12 5 is 60 I2 equals to 50. On changing the sign, we get plus and here minus and here minus. Wait, no need to change the sign here because we can cancel them as it is here. I2, that is 60 I2 get cancels directly. Then 240 Ig minus 10 Ig becomes 230 Ig. 230 Ig equals to 50. That is Ig equals to 15 divided by 230 ampere. 15 divided by 230 ampere. Or else we can write Ig can be written as Ig equals to 15 divided by 230. 0.065 ampere. So Ig equals to 0.065 ampere. That is current through the galvanometer is 0.065. In this way, we need to solve such type of numericals. let me move to the next question. That is, an AC source of 200 volt 50 hertz is applied to a series LCR circuit in which R is equals to 3 ohm, L equals to 25 millihenry and C equals to 790 microfarad. Find the impedance of the circuit and current in the circuit. So as we all know that an expression for the impedance, that is Z equals to square root of R square plus XL minus XC whole square. This is the expression for impedance in the LCR circuit. So here we know that R we have directly 3 square we can substitute here, but we don't have XL and XC. First let us find out XL and XC. So we know that XL is equals to XL, that is nothing but inductive reactance, that is equals to 2 pi FL. So I'm substituting the values, that is 2 into 3.142 into F is 50 hertz, here 50 hertz, and L equals to, it is 25 millihenry, 25 into 10 raised to minus 3. Here we can write that 2 into 3.142 into 50 into 25 is equals to 7855 into 10 raised to minus 3. This can be written as 7.855 ohm. This is what inductive reactance. Now let me find out XC, that is XC equals to, that is capacitor reactance is equals to 1 divided by 2 pi FC. Here now substituting the values, that is pi value is 3.142 into frequency is 50 and capacitance is 790 microfarad. So I'm simplifying, we get 10 to the power minus 3, so minus 6. If it goes up, it will become 10 to the power plus 6 divided by 2 into 3.142 into 50 into 790, 2,48,218. So this is 10 to the power 6 divided by this one, 2,48,218 is 4.028. This is XC. Now substitute this XC and XL in this expression, that is Z equals to square root of R square. R square means 3 square, that is 3 square plus XL. XL equals to 7.88855 minus 4.028 whole square. So we know that Z equals to square root of 3 square means 9 plus 7.855 minus 4.028, 3.827 whole square. This can be written as, that is square root of 9 plus 14.64. This is equals to 23.64. Square root of 23.64, 4.86 ohm. So this is what the impedance equals to 4.86 ohm. Okay, next we need to find out current in the circuit. So we know that current in the circuit is equals to, that is I is equals to, that is V by Z. This applied voltage is 200 volt and Z just now we found that is 4.86. .15 41.15 ampere. Let's go to the next question. That is, the refractive index of an equilateral prism is 1.532. Calculate the angle of minimum deviation when it is immersed in water of refractive index 1.33. So let me take refractive index of the prism, equilateral prism, as Ng, that is equals to 1.532. Refractive index of the water is 1.33. When it is immersed in water, refractive index of the glass with respect to water, that is refractive index of the prism with respect to water, is equals to refractive index of the prism divided by refractive index of the water. This can be written as sin A plus D divided by 2 whole divided by sin A by 2. This is the relationship between refractive index and angle of minimum deviation. Okay, now Ng equals to how much here? 1.532 divided by refractoriness of the water is 1.33, and the sine angle of the prism for equilateral prism is 60 plus d whole divided by 2 sine 60 by 2. We could write 1.532 divided by 1.33, that is equals to 1.1518 is equals to sine of 60 plus d divided by 2 whole divided by sine 60 by 2 is nothing but 0.5. That is sine 60 by 2 is sine 30. Sine 30 value is 1 by 2. 1 by 2 is nothing but 0.5. Now 0.5 into 1.1518 is equals to 0.5759. This is equals to sine of 60 plus d whole divided by d. Now let me bring sine to the left side, then it becomes sine inverse of 0.5759. So it becomes now 60 plus d whole divided by 2 is equals to sine inverse of 0.5759. Let me find out now the value of sine inverse of 0.5759 by using sine table. Here we need to find out 0.5759. Here you can see the 0.57 is 0.5736, 0.5750, 0.5764. The nearest value should be found. 0.5759, which is very close to 0.5764. So 0.57 here, the 35 degree we have, and here 0.64. The difference between 0.64, 0.5764 and 0.5759 is 5. Let me look at the mean difference, that is 5. So here we have 2 minutes. So let me subtract 2 minutes from 12 minutes, then we get 10 minutes. Okay. This is the value of sine inverse of 0.5759. That is 35 degree, 10 minutes. That is 60 plus d, that is 60 plus d divided by 2. 60 plus d divided by 2 can be written as 30 plus d by 2. And here we have 35 degree, 10 minutes. Let me write 35 degree and 10 minutes. In terms of degree, let me write here. So we know that 60 minutes equals to 1 degree, and here we have only 10 minutes. Let me write 10 minutes equals to x degree. Let me find out now x value. X degree equals to, on cross multiplying we'll get 10 minutes divided by 60 minutes into 1 degree. This equals to 10 by 60, 0.166. So we can write here 0.166 degree. So it will become now 35.166 degree. That is what 30 plus d by 2. Now let me write d by 2 is equals to 35.166 minus 30 is equals to 5.166. So degree. So we will get here d equals to 5.166 into 2 is equals to 10.332 degree. So this is what the angle of minimum deviation for the given equilateral prism. Okay, let's go to the next problem, that is calculate the binding energy and binding energy per nucleon of an alpha particle in mega electron volt from the following data. Alpha particle, it resembles helium nucleus. Mass of alpha particle is 4.00260 U. Mass of the neutron, mass of the proton we have. So here, as we all know that the binding energy is nothing but mass defect times 931.5 mega electron volt. This is the value of binding energy. What is delta M? Delta M is the mass defect. Mass defect is the difference between the sum of the mass of the nucleons and actual mass of the nucleus. That can be written as ZMP plus E minus Z mass of the neutron minus actual mass of the nucleus. So this is sum of the difference between the sum of the mass of the nucleons and actual mass of the nucleus. So let me substitute now Z. Z for alpha particle is 2. Mass of the proton, here we have 1.007825 plus A minus Z. A minus mass number and atomic number. A minus Z is 2. That is A is 4 and Z is 2 for alpha particle. So we will get here 2 into mass of the neutron is 1.008662 minus actual mass of the nucleus is 4.00260 U. I'm simplifying this. 2 into 1.007825 is 2.01565 plus 2 into 1.008662 is 2.017324 minus 4.00260. Now if you simplify this, 2.01565 plus 2.01734, that is equals to 4.032974 minus 4.00260. So if you simplify, you get the mass defect, that is 0.030374. This is the mass defect. Actually, what we need to calculate? We need to calculate binding energy. And binding energy equals to delta M times 931.5 mega electron volt. So now binding energy is equals to delta M is equals to how much here? 0.030374 into 931.5 mega. 931.5 mega electron volt. If you multiply this, we get binding energy is equals to 28.2933 mega electron volt. This is binding energy of the nucleon of an alpha particle. And one more factor we need to find out, that is binding energy per nucleon. Binding energy per nucleon is also called as specific binding energy. That is specific binding energy. That is binding energy per nucleon is equals to binding energy per mass number. So here binding energy is equals to 28.2933 we got 2933 mega electron volt divided by mass number is 4. So we will get here 28.2933 divided by 4 is equals to 7.0733 mega electron volt. This is binding energy per nucleon. That is binding energy per nucleon. In this way we can solve the problem. Okay. Thank you. Thanks for watching.